Hey gang, the situation or scenario may exist in the confines of EIGRP where I don't want to have anything other than just a default route. Now what I want to do is I want to illustrate on R1 and on R22 just like we did before, but because of the fact that we now have discussed the nuances of where we need to do our configurations, Ray, named mode versus classic EIGRP operation, we should be able to just wrap this particular video up without having a separate segment for each of the two different components. So when it comes to advertising these prefixes, what I want to do is I want to remove my previous config. So when I come up here and say show run interface E0 or S20, I want to get rid of these configs. So interface serial 20, and I'll just simply copy and paste this and take it out. So no plug place gone. So let's go ahead and do the same thing for 2/1 gone. So now we'll go over to R1 and do the same configuration. However, show run section router. Remember, I need to do it inside the confines of my EIGRP named config. So we'll go ahead and just grab this one right here and say config T, paste that in, advance to the end and say no. Up arrow here, get this one out of the way and say no here. So what ends up happening now is from the point of view of R1, show IP route, I should have load sharing going on to reach my 12 interfaces. My 22s, excuse me, which I do. Let's test it. Trace route 22, 22, 0, 22, and I'm load sharing. And now also on R22, show IP route, I should have all of the prefixes that I'm learning via 11. And it looks like I'm going to load balance there, so let's do trace route 11, 11, 0, 11, and I am load sharing. So the result here is we've just removed all of our configuration and we have all of these interfaces that we're advertising. Now what I'm going to do is I'm going to go to R22 since it's the classic configuration, and I'm going to say config T interface serial 20 IP summary address, and I'm going to specify EIGRP 10, and I'm going to say I want to summarize 0.0.0.0.0/0. Now let's see what happens. This, ladies and gentlemen, is a default route. So now if I come up here and say to 1, I want to do the exact same thing. Now when I go over to R1 and type show IP route, let's see what it is we're looking at here. Notice this device has learned a static default route. So now here's the situation. I've learned this via D, which is EIGRP. It is a candidate default route. I'm learning it from both Cat2 and Cat1 via Ethernet 0, 1, and 0, 0. And now what I want to do is I want to play with reachability. So let's say ping 10 or 11, 11, 0, 11. Let's do a trace route to 11, 11, 0, 11. Oh, I'm pinging myself. Duh. 22, 22, 0, 22. There I'm on my trace route. And let's do the ping. And I have reachability. So in this situation, the question now is what happens if I make a new prefix? Let's go over and do something completely unexpected on R22. Do show IP interface brief, say E assigned, exclude anything that has assigned in it. So anything that has the ASS in it or UNASS in it is going to be removed, so exclude. So that's going to give me only interfaces that have IP addresses. Let's create a new loopback. Let's say interface loopback 1000. And let's give it an IP address. Let's say IP address 172.31, and we'll say 22.222.222, 255.255.255.0, And now let's look at this. Let's show IP EIGRP interface, and notice that loopback 1000 is not participating in EIGRP. However, from the point of view of R1, show IP route to 172.32 or 31, 222.222. Hit enter. It's not in my routing table. Let's make sure I'm using the right interface or the right address. Yep, 31.222.222. However, if I ping 172.31.22.222, well, 222.222, and I hit enter, I have reachability. Now what's happening here is that let's look at R22. Debug, actually config T, access list, let's do this, no access dash list, say 100, specify access list 100, deny EIGRP any, access dash list 100, permit IP any, debug IP packet detail using access list 100. This is going to allow me to ignore any packets that arrive on my device that are going to be sourced or destined to our EIGRP. So it's going to be the protocol that we're going to be using is now going to be turned off. It's not turned off, we're just not going to see any output. So what I'm going to do is I'm going to go to R1 and I'm going to redo this ping. Now we see here, notice it changed to blue right here. Now by cutting back over to R22, I'm going to see the information. Notice it says it was sent. See, the source, see, that's the one back. Let's see, I need the one coming in. Okay, something came from 10.1.101.1 via serial 2/1, and it was destined for the address of 172.31.222.222. Now when we look at this, notice it says packet routing failed, but that what's happening here is we have to recognize the fact that the system doesn't understand some elements here. So let's see here, we should have reachability for all of this. Let's do a trace route on this. Let's see what's going on here. So trace route to 172.31.222.222. And we're load sharing. So we have the reachability. The packets are actually making it to R22. And we can see here that the information is associated with what it is, like the destination address and the source IP address. All I want to do is just illustrate the fact that by virtue of the fact that we have this default route, now I can send anything that I do not have a more specific prefix in my routing table. I can now send it using my default route that I'm learning via EIGRP. And let's take a look at where we're learning that. So let's see, show IP route EIGRP. Notice what happened here. I have my gateway of last resort, 00. The system is advertising this because it's actually sending it to null 0. Now here's the scenario. What happens in a situation where if I had, let's say I have a prefix here. This prefix we said was 172.31, and I don't remember what, I think it was 0. No, it was 222.222. And it's on this physical interface. Now I'm advertising a default route, what I call a quad 0 prefix, out both of these interfaces, serial 2.0 and serial 2.1. Now that means that that's going to ultimately be propagated all the way down, which is why we're doing load sharing here on R1 to reach these destinations. But what would happen if I had if I did not have an interface here of say 200.0.0.222? Let's say I wanted to be able to reach that address, but that address does not exist on R22. Well, what would happen is by virtue of the fact that it doesn't exist and there's not a more specific prefix, EIGRP incorporates a loop prevention mechanism that's going to actually send any of that traffic to a null zero interface, or what is lovingly referred to as the bit bucket. So in other words, we're going to drop that packet. We're just going to shunt it straight to an interface that doesn't exist, an interface that we're referring to here as null zero. Now, that process takes place whether I'm doing an EIGRP summary for a default route or whether I'm using or just doing a regular summary address. In the context of a routing protocol like RIP or even RIP Next Generation, remember it did not automatically create that static route to null zero in order to be able to prevent the possibility of loops from occurring in our environment. Let's take a look at this. So what I'm going to do is I'm going to bounce back over to well, actually, while we're over here on R22, let's verify show IP interface brief E assigned. Notice that I don't have an address here for 200.0.0.222, but that's not going to stop R1 from trying to reach that. Let's take a look at this. We will ping 200.0.0.222. Repeat. I'm going to do it one time. Notice it's coming back and it's telling me it's unreachable. But notice right here, it's telling me that I am, let's see, not telling me anything. Let me clean this up. IP sourced from 10.1.223.222 is coming up, sending, here it is, this is what I'm trying to grab right here. Notice it said sourced from 10.1.101.1 came in on serial interface 2/1 and it was destined to 200.0.0.222, and what did it do? It sent that directly to the interface null zero via the routing information base that we have running on this particular device. This would prevent this particular prefix from bouncing around my infrastructure ad infinitum, or at least until the TTL expired. So bear in mind that we have the capability of being selective with regard to how we want to do summarization, and we can also be selective with regard to how much we want to be able to advertise. So the idea here is that what we have to recognize is I can be picky about which prefixes I want to summarize for, or I could say just summarize everything, I'm not going to anywhere, something that's very, very common with regard to something called a stub network. As an example, these remote site offices right here, those will lead nowhere. So it would be perfectly fine if they had a default prefix that would allow them to be able to communicate to everything outside the infrastructure, especially if these were smaller, underpowered devices that were located in these branch offices. The main thing here is there's no reason that this device should be burdened with the IP address of every other device in the infrastructure if it's not transit to reach that via any other way. So again, when we talk about EIGRP stub networks, this is going to be one of the things that we're going to talk about. But what I also want to point out here is when it comes to summarization, we can be even more granular. Let's find out how and why we'd be interested in doing that in the next video. I'll see you guys there.